So I may or may not be making it in tomorrow, and given a flight delay, so we're going to go ahead and just record this for you guys. To start, you're going to see a lot of times these negative 1 to the n plus 1s times negative 1 to the n's, or negative 1 to the n plus 1s times 1 to the n's, or 1 to the n plus 1 times 1 to the n, and you need to be able to simplify them. So let's kind of work with these and just sort of simplify the gist of this. If I have negative 1 to the n plus 1 times negative 1 to the n, a couple ways to think about that. One of them is that there's always going to be a negative 1 term in no matter what. I could also think about this as negative 1 to the 2n plus 1, which is just negative 1 to the 2n times negative 1 to the 1. But that means that this is going to be 1, and you're just going to get a negative 1. So I like to think about this as negative 1 always. The next one is if I have negative 1 to the n plus 1 times 1 to the n. 1 to the n is just 1, so that is just negative 1 to the n plus 1, which is a true alternating negative 1. Finally, if I just have this, 1 to the n plus 1 times 1 to the n, that is 1. And those go away completely because both of those are just representations of 1. So now we're going to consider this series. We're going to consider the sum from n equals 0 to infinity of x to the n. This is a representation of a series that looks like this: 1 plus x squared plus x cubed plus x to the 4th, and so on. And the thing that we're going to ask is what type of series is this? We can consider this to be a geometric series with an r value of x. And this is a series, this geometric series converges when the absolute value of r is less than 1, which also means, since r is x, when the absolute value of x is less than 1, which is to say that x falls in between negative 1 to 1. So if this is true, if the absolute value of x is less than 1, if this converges, then we can say the sum is equal to t of 1 over 1 minus r, which is 1 minus x. So that's kind of the setup for how this is going to look. It's going to be very similar to geometric series. I'm going to say very similar to geometric. And this particular type of series is called a power series. It's a power series where p of x is equal to the sum from n equals 0 to infinity of a sub n times x minus c to the nth power. So I kind of think about this a sub n as being a series, and this x minus c to the n as being the power. And this will be kind of equal to a sub 0 plus a sub 1 times x minus some c value raised to the first power plus a sub 2 times x minus c to the second power, and so on. So let's dissect this a little bit. N is determined by the specific term value of the series, or of the power series. C is a constant. Much like we used before with Taylor polynomials, C is a constant called the center of the power series. We often choose C is equal to 0, and a sub n's are the coefficients of the x minus c terms. So again, think of the a sub n's, the series themselves. These are coefficients, and the x minus c to the n is the specific power of the value that we're looking at. So let's look at some examples of how this is going to look. Number 1, find the center and find a sub 20 for each of the following. So the sum from n equals 0 to infinity of x sub n over n factorial. Which, by the way, if I split this up and make it look more like a power series, I get 1 over n factorial times x sub n. So again, 1 over n factorials, these are the coefficients, and n factorial, these are the powers or the terms of the series. So, well, since it's x to the n, we know that the center is at 0. Hang on, I'm going to put a little a value here because that's the first of several. Center is at 0, and a sub 20, which is the 20th term's coefficient, is just 1 over 20 factorial, which you obviously can't really simplify without a calculator. So the next one, the sum from n equals 0 to infinity of negative 1 to the nth power times x plus 1 to the n. This is an alternating series that has a center at, well, we can see from this term here, if this is an x plus 1, then the center is at x is equal to negative 1. And then my a sub 20th term is negative 1 to the 20th, which is 1. Finally, I can do another one, the sum from n equals 0 to infinity of 1 over n times x minus 1 to the nth power. This, because of the x minus 1 term, has a center at x is equal to 1, and the 20th coefficient is 1 over 20. So that's the first set. Next set of questions. Use p of x is equal to the sum from n equals 0 to infinity of negative 1 to the n times x plus 1 to the n to find p sub 3 of x, which we can think of as an approximation of p of x. Remember, that's a third term approximation of this. So p sub 3 of x equals the sum from n equals, well, I want to do 3 terms here, and so we're going to kind of say that p sub 3 of x we're going to define as 3 specific terms, n equals 0 to 2 of negative 1 to the n times x plus 1 to the n. So in this case, again, I'm going to use p sub 3 to mean 3 terms. So since we're starting at 0, I'm just kind of setting that apart, or setting that my 0th term represents 1 term, and we're going to say that p sub n of x refers to n terms of p of x. So p sub 3 starts from n equals 0, goes to 2, because I want to have 3 total terms. So let's get back to this. P sub 3 of x equals, let's do negative 1 to the 0, x plus 1 to the 0, plus negative 1 to the 1, times x plus 1 to the first, and plus negative 1 squared, x plus 1 squared, which is to say negative 1 to the 0, this is 1, minus x plus 1, then plus x plus 1 squared. So that is the third term polynomial of this. Next, we're going to discuss something that we've been kind of alluding to, the intervals and radius of convergence. And when we discuss radius of convergence, really what we're saying are what values of x does the power series converge? Because convergent power series are very, very valuable, and not all of them will converge at all times, but they could converge at some times. So let's examine this one, the sum from n equals 1 to infinity of 1 over n times x minus 1 to the nth power. A couple of questions on this one. Actually, we'll kind of put this as a multi-part question. does it converge at x equals 0, x equals 1, x equals 2, and x is equal to 1/2. So to answer this question, we're just going to examine these at the different places. At x equals 0, we have the sum from n equals 1 to infinity of 1 over n times -1 to the nth power, which is the sum from n equals 1 to infinity of the -1 to the n over n. You may recognize this as the alternating harmonic series. And you should know that the alternating harmonic series converges by converges by alternating series convergence test, which I'll leave up to you to do or to remember. And if you don't remember the specifics of that, you need to go back and review it right away. The next one, the sum from n equals 1 to infinity of 1 over n. So at x equals 1, we get 0 to the nth power. And 0 to the nth power times 1 over n is going to be 0. So that clearly converges because that sequence is just the sum of an infinite number of zeros. Next, we've got x is equal to 2. When we have n equals 1 to infinity of 1 over n times, kind of coming back up here, this is 2 minus 1 to the nth, or 1 to the nth power, which is, if I cut that out, that is just the harmonic series. And we know that the harmonic series diverges. That's a divergent p-series. Can be proved with the integral test. Okay. Finally, x is equal to 1/2. We get the sum from n equals 1 to infinity of 1 over n times -1/2 to the nth power, which is the same as the sum from n equals 1 to infinity of, well, the -1 to the nth is -1 to the nth, that's the alternating part, over n times 2 to the nth power. And we can look at this one. We can actually do a number of different tests to prove this, but we can also prove it by the alternating series convergence test, since this approaches, or this particular series approaches 0. So we know that this converges. I'm just going to kind of write converges here, because really we're just looking for the convergence of it. We're not looking for absolute or conditional. The radius of convergence. To get the radius of convergence, what we're going to do is we're going to take the limit as n approaches infinity of, and we're going to do an nth term test, because what we need is the radius of convergence is when the common ratio is less than 1. In order for this thing to actually converge, the common ratio has to be less than 1. Well, the common ratio can be found by doing x minus 1 to the n plus 1 over n plus 1. So if I kind of look at that, this is just basically the ratio test. Looking way back up at mine, x minus 1 to the n plus 1 over n plus 1 times the reciprocal n over x minus 1 to the n. And I want this to be less than 1. So as n approaches infinity, what I in effect get is I get x minus 1. And so basically this happens when x minus 1, its absolute value, is less than 1. And that means that x is in between -1 and 1. This right here is called the interval of convergence. And the radius of convergence is 1. So the radius of convergence is 1. The center, C, is equal to 1. And the interval is from, well, this wouldn't be from -1 to 1. I'm sorry. If the center is at 1, this would actually solve to be between 0 and 2. So the interval is 0 to 2. Now, the thing is I actually have to check if it's 0 to 2, I need to check my endpoints. So I'm not really checking right now. I know it's in between 0 and 2, but I don't know if 0 is going to work or 2 is going to work. So let's slide back up to here. 2 caused it to diverge, x equals 2. 0 caused it to converge. So because of that, 0 is a closed and 2 is an open. And I'm going to make that reflect right here by adding this little closed in there. So what I'm going to say is that we must check endpoints using the technique we did up above. So let's try another one. Number 4, the sum from n equals 0 to infinity of n factorial x to the n. And that's going to be equal to, if I kind of write this out just so you can see it, that's equal to 1 plus 1x to the first plus 2x squared plus 3x to the, or 6x to the third plus 24x to the fourth, and so on. Okay, so we're going to do a ratio test now on this series, and we're going to try to set the ratio test so that it has an interval less than or equal to 1. So let's do the limit as n approaches infinity of n plus 1 factorial x to the n plus 1 divided by n factorial x to the n in absolute value. And if I do that, I get the limit as n approaches infinity of, well, we get n plus 1 times x. So that is going to be less than or equal to 0 nowhere, because you're always going to have this limit is actually infinity, and infinity less than 0, no. So we know that this basically diverges everywhere except for one spot. It diverges everywhere except at x is equal to 0. So remember, we're trying to figure out what values are going to make this actually be less than 1. And the only values that are going to work for this limit as n approaches infinity would be at x equals 0. So what I can say is that diverges everywhere except x equals 0. The radius of convergence is 0, since it's at one point, and the interval of convergence is just the number 0. Okay. Next, let's do the sum from n equals 0 to infinity of x to the n over n factorial. So this is similar, but we're going to divide by n factorial. So this is 1 plus x squared over 2 plus x cubed over 6 plus x to the fourth over 24, and so on. So we're going to do the limit as n approaches infinity of the absolute value of x to the n plus 1 over n plus 1 factorial. I'm going to multiply that by the reciprocal of the other, n factorial over x to the n, an absolute value. I get the limit as n approaches infinity of x to the n plus 1. So this is just x over n plus 1, my bad. And then, let's see. So that limit is 0. And this is 0. So I'm going to say is no matter what x is, this limit is 0. So this means that the radius of convergence is infinity. It's convergent everywhere. No matter what happens, this 0 is less than 1. So radius of convergence is infinity, and the interval of convergence is negative infinity to infinity. It may be helpful to see an example that looks a little bit simpler without all this notation. So let me just give you something like this, just to remind you on how to solve absolute value inequalities. If I get something like that, you can multiply both sides by 9, because the absolute value of 9 is 9, But then what you're really saying is that -9 is less than 2x minus 1, which is less than 9, or -8 is less than 2x, which is less than 10, or -4 is less than x, which is less than 5. So given that interval of -4 to 5, we would say that the center is at the average of those, which is 1/2, and the radius is half of 9, 9/2. So that's just kind of a little thing for you. Okay, so let's summarize. P sub f is equal to the sum from n equals 0 to infinity of a sub n times x minus c to the n must either a converge at x equals c and diverge elsewhere. And if that's true, we have a radius equal to 0. You can converge at all x, in that case the radius is infinity, or converge on x minus c is less than r with either both or neither endpoint. And in that case, you must test. And if this is also true, your radius is r. And we're done.